Okay, chapter 1 review. Find the point of intersection by graphing, which means you have to use the graph. When I came around to do the homework check, I saw a lot of you guys just wrote the intersection point. I needed to see the graph, and on the test, you'll get marks for showing the graph. So this one, my y-intercept is 8, so I'm going to plot this point right here, and the slope is 4, so up 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. So like this. And then there's my line. Okay, technically you only need the 2 points to draw the line, but if you do a few more points, it's going to be more accurate. Second line, my y-intercept is 1. And my slope is 1 over 2. So up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. Okay, so when you connect that, you can actually see it crosses over here, right here. That's my POI, point of intersection, and the coordinate is -2, 0. Okay. Second one. This one is not in y equals mx plus b form, so I have to rearrange it. So y equal, move the x over, -x plus 6. And the second one, when I rearrange it, this will become, here, I'll do it in the step like this. -y equals -2x plus 6. So when I move that negative over, I get y equals 2x minus 6. Okay, so for the red line, y-intercept is 6. Plot that point. My slope is -1. So down 1 over 1, down 1 over 1, down 1 over 1. Okay. There's my first line. Second line, -6. -2, 3, 4, 5, 6. Right here, that's -6. And up to over 1. 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 Alright, there's my intersection point. Right here. So my POI in this case is 4 and 2. Okay. Oh, hey, he's good? Okay, perfect. Do you have a Chromebook? You do? In your bag? Okay, so if I can get you to just sit there. Let me just change. Okay, any question on the graphing? Okay, all good. Next, what is the intersection point of these linear systems solved by substitution? Okay, so looking at this, the first equation right here, this looks like it's the easiest variable to isolate. So b equal -5a plus 4. I'm going to sub this in for this b right here in my second equation. So 3a plus 2. Make sure you put it in brackets. So -5a plus 4. Close that bracket equals -6. Distribute, distribute. 3a minus 10a plus 8 equals -6. So -7a equals -14. So when you divide that -7, you get a equals 2. Right? Don't forget to plug it back into here to find out what b equals. So -5, sub into 2 plus 4. So b equals -10 plus 6, so -6. -10 plus 4 gives you -6. So my POI, 2, -6. Okay. Second one right here. Again, this one, I have the x by itself, so this is the one that I want to isolate. So x equals 2y plus 5. Okay. I'm going to sub that in for here, for this x. So 2 bracket 2y plus 5 plus 3y equals 17. Okay, so Gia, go to quizzes on the top. And then the chapter 2. Okay. Distribute. So 4y plus 10 plus 3y equals 17. Add that up, you get 7y. Move that over, you get 7. So when you divide it, y equals 1. Sub that back into the x equation. So x equals 2 times 1 plus 5. X equals 7. So my POI, point of intersection, 7, 1. Let's say you finish the test really early tomorrow. You could do this other method and see if you get the same answer. Right? So remember all 3 methods, you should be getting the same answer no matter which method you use. Okay? Back page. Which 2 equations are equivalent? Circle the 2 and explain why. So, who has the answer for number 3? Yep. B and C. Okay, let's see if she is right. So, let's change this into y equals mx plus b form. So, we want to change it to y equals mx plus b. That means we have to move this 2 over by dividing everything by 2. So this becomes y equals half x plus 4, which is exactly same. Okay, if they are the same equation, how many solutions does this system have? How many solutions? Okay, do we have no solution? No solution. 1 solution. Or infinite number of solution. Okay, so given these 2 equations as your linear system, which one is my correct answer? 1, 2, or 3? Yep, 3. That's right. Because these 2 lines, if you were to graph it, it's like this. And this second line is like this. So they overlap each other. So what is their intersection point? Every single point. So infinite number of solutions. Okay. Find a point of intersection using the method of elimination. So again, telling you which method to use. Okay, so looking at these, none of the coefficients match up. So I have to multiply. Let me go back to this. Let's say I want to get rid of the x. So I'm going to multiply my top equation by 5, multiply the bottom equation all by 3, so that I can get the same coefficient. So 15x plus 20y equals 35. Answer 15. Yes. Yeah. Thank you, Belinda. Sorry for the confusion. Okay, sorry about that. So 5 times 3, 15x, plus 3 times 3 is 9y, equals 24. To eliminate the x, 15x plus 15x doesn't eliminate them. 15x minus 15x. So that's why I have to subtract the two equations. When I subtract it, that's good. 20y minus 9y is 11y. And 35 minus 24, you get 11. So when you divide, y equals 1. Okay. Next step is I want to substitute it into either equation. So let's say I substitute it in that. I get 3x plus 4 times 1 equals 7. So 3x equals 3. When I divide it, I also get 1. So my point of intersection here, 1, 1. Do you need a drink? You're okay? Okay, you okay?
I kind of just choked on it.
Oh, okay. Okay, this second one right here. So it's actually very similar. Okay, so let's say I want to eliminate the x again. Okay, so this is very similar. I wish I did one with different. Actually, you know what? Yeah, this one is just the same. So I'll. Do you guys need me to take up this one? It's the same. Everything is the same. I wish I had one with a different number, different sign, like a positive, negative. So you can see me if you want me to show you this individually. Okay, but we'll move on. Word problems. Okay, so I think these word problems, the next 3 word problems, are ones that you really want to pay attention to. Make sure you got the right equations. So Daniel has a total of 126 Canadian and British stamps in his collection. He determines that he has 38 more Canadian stamps than British. How many of each does he have? So we have our 2 variables. Word problem, you want to make sure you write a let statement, because otherwise I don't know what x and y are. So let C represent number of Canadian stamp. Makes sense to me. And then let B to represent number of British stamp. Okay, so the first equation, remember, is always the number of. So in this case, it says you have a total of 126. So what's my first equation? Yeah. Perfect. Okay. And then my second equation is my second clue right here. This part. Kelly? Okay, so C equals B plus 38. Good. Remember the little trick I taught you guys on Thursday or Friday? The one that has more, you want to write it as the first variable. That equal, and then whatever you have to write. Okay. So looking at this, if I give you guys these 2 equations, which one of the 3 methods is the easiest to use? If I give you these 2 equations in this format, who says you will solve it by graphing? Who says solve by substitution? Who says elimination? But it's all set up. So those who say substitution, I like substitution. Why? Catherine? Right, you have C already isolated. Okay, so the type of communication I could ask you on the test. Right, so it's already isolated. I don't have to do an extra step of like moving anything over, rearranging equation. So I'm going to substitute this into here. Sub equation 2 into equation 1. So b plus 38 equals 126. So 2b equals, what's 126 minus 38? 126 minus 38, 88. So b equals 44. 44 what? Kelly? Not enough.
Okay, British stamp.
British stamp. Why am I being so picky?
Because there's Canadian stamps.
Yeah, you have two types of stamps. So you have to tell me, like, imagine if you use X and Y, and then you say X equals steps, and I'm like, which type? You have two types right here, right? Just because your variable is B doesn't automatically assume that it's British step. So you do have to specify which type because you have two different types of steps here. Right? Now substitute it back into this equation to find out how many Canadians we have.